Okay, hi everyone. So today we're going to be looking at internal and external division when looking at HL math in the vectors unit. Okay, so I'm going to share my whiteboard. And so I have this internal division problem set up in which the point A is 3, 7, 12 in order from X, Y, and Z respectively, and point B is 2, 9, and 7. And then what I think is most helpful when approaching these problems is drawing a number line so that you know what you're looking at. And I think it's helpful to also draw it in scale so that you kind of get a visual representation of what the ratio looks like. So for this problem, I set up the ratio as 3 to 1. So that's relatively easy, but I think it's just easier when dealing with the fractions and things like that. So as I said earlier, it's 3 to 1. So what that means is that AP is 3 and you could say PB or BP is 1. And so in order to like formally write out this problem, I think it's just helpful to establish that relationship. So we have AP to PB is 3 to 1. Sorry, let me remove that. Equals 3 to 1. So I think just establishing like that ratio itself is very helpful in terms of understanding the question in general. So now that you have that ready, you can establish a relationship between the way you have to solve this problem. So since you know that AP is 3 and PB is 1, then you also know that AP, right, a little smaller. You also know that AP is going to be 3/4, sorry, 3/4 of AB, right? And so you know that because the whole thing, AB is 4, and then P splits it in a ratio from 3 to 1. So that's like the way to summarize this question. So AP is 3 and AB is 4. So 3 is just 3/4 of 4. Simplest way to put it. So because of that relationship, you also have to, now you can set up the equation. Sorry, I'm all over the place. So AP would be set up by, so whenever you're setting up these problems, you want to make sure that it's P minus A and B minus A. So it's the letter on the right that that comes first when you're subtracting. So P minus A would, so for each, you have to set that up for each coordinate. So it'd be X minus 3, right? And then Y minus 7, and then Z minus 12. So that equals, and I'm going to use a different color, 3/4 of, and then that would be 2 minus 3, right? So -1, and then 9 minus 7, so 2, and then 7 minus 12, so -5. So this is essentially what you want to do. And from here, it's relatively easy to solve the problem, because you just have to set up the different, um, you just have to set up the different equations. So I'm going to erase this middle section over here and move everything up so that we can solve this problem. Okay, so let's start with x. So x minus 3, sorry, x minus 3 equals 3/4 times -1, which is just -3/4, right? And so 3 is 12 over 4, so that's simply just x equals 9 over 4, right? And then you have y minus 7 equals 6 over 4. And so that would just be 28 over 4 plus 6 over 4. So y equals 34 over 4. Oh, sorry. 34 over 4. And then z minus 12 equals -15 over 4. And so that would be -15 over 4 plus 48 over 4. So z equals 33 over 4. And so now that you have your x, y, and z coordinates for point P, you can figure out point P. Exactly. So the answer to this question, or the answer that you were looking for, is what are the coordinates of point P? And so now that you have that, you can answer this question. So the answer is P, and then you can set up your parentheses like we did for A and B, would be 9/4, and then 34/4, and 33/4. Did you also get that? Okay.
Yes,
Good.
I did.
Great. Okay. So internal division, I think, is a little easier than external division, just because external division is like sometimes hard to apply. So this is internal division. Now we're going to do a practice problem for external division. So we're going to use the same numbers. So let me just write those down again. So A is 3, 7, and 12. And B is 2, 9, and 7. So I'm going to set up the same exact problem as before, the same number line, except it's going to look a little different this time. So this time you want to make sure that AB is being extended to a random point Q, and the ratio that we're trying to set up here is also 3:1. But this time it looks a little different. So it's not a straight line. Okay, so we have A here, and then you have, let's say, B here, and then Q here. So this is the line that you have. So I'm going to label those Q, B, and A. And then I think it's helpful to draw the arrows just so you know like where it ends. And I think an important part of this question is to understand that there's also like this relationship, like there's an arrow in the other direction to kind of understand that the ratio is negative when you put it in a different way. So let's set up the ratio. So we said 3:1, right? So that means that the whole thing, AQ, is 3, right? And that would mean that AB is 2, right? And then the other part, QB or BQ, however you want to say, is 1. And so that's exactly what this problem said before. So once again, I think establishing that relationship is helpful. AP to PB, sorry, not PB, QB, right? And because they go in opposite directions, QB goes to the right and AB goes toward AB goes towards the left. I established that relationship as -3:1. And I think that's just helpful to understand like the ratio. And so now that you have this relationship established, or like the ratio as mentioned in the beginning of the problem, you can move on to the next step, which is actually solving it. So now we can set up this problem. So we know that BQ is 1, right? And we know that AB is 2. So because BQ is 1 and AB is 2, we know that BQ is 1/2 AB, right? So that part makes sense. And so the next thing you do is do exactly what you did for internal division. So you have to set up these parentheses, I guess is what you call it. So you would set up x minus, this time it'd be, you use the b coordinates, right? So x minus 2, y minus 9, and z minus 7. And here you do the same thing. So 2 minus 3, -1, 9 minus 7, 2, 7 minus 12 is -5. So now that you have this, I guess these established, you can just simply solve for the problem. Oh, yeah, there we go. So first, let's start with x. So x minus 2 equals -1/2. And then that would just mean that x equals 3/2, right? And then you can do y. Y minus 9 equals, what is that? 1, yeah. So y equals 10. And then you do z, and I'll do z on the right side just because I'm running out of space. Z minus 7 equals negative, no, yeah, -5/2, right? And so then you add 7 to both sides and you get z equals, so -5/2 plus 14/2, 9/2. So these are your three components that you were looking for. So coordinate Q to answer this question is 3/2, 10, and 9/2. So that's how to do an external division problem. Um, it's relatively easy and compared to the rest of the IBHL math topics, but I think it still can get lost in translation sometimes. Okay, thank you.